Good morning, students. Today we'll discuss about software engineering and models. So myself, Professor Manohar Kodmelwar. So regarding software engineering, we know that it is a very systematic process. From a lot of long years, we are using this. Today we'll discuss that what is the importance of software, as well as how we can implement that standard procedures in our project development, and what are the different models which are developed to create the different types of simple as well as complex projects. So in this PPT I am going to cover these are the contents like history, what is software engineering, software versus hardware, nature of software, myths, process, waterfall and incremental model. We will discuss. So related to the history, we can see that in 1965 we can find some of the origins related with this by the Douglas in MIT in 1950. We find he has proposed that particular software engineering. And second, we can find the Margaret Hamilton. She came up with the idea of naming this discipline as a software engineering to develop this particular, or we can consider as a discipline where we can use some standard processes, standard rules, and it exists that we should follow this. So she proposed that software engineering can be one discipline, which for a long time we are using, but we have not given any particular name to this process, but it should be used. So she proposed that software engineering should be a discipline. Then going into the detail, that is what is the software engineering. We can see that now I told that it is now considered as one engineering discipline. In that we are going to develop this particular project. Again, we can see that it is a systematic and organized approach. Systematic means what? Step by step. It's not like randomly directly we are taking the problem statement from customer and start developing this particular project. So if we follow some systematic and organized approach, really we can have the good project at in last we can find. Then by using this systematic and organized approach, some tools and techniques also we have to use related to this development. So by using these techniques, different models are there. We can use these models. Some tools we can have to develop this particular which can generate the test cases, and which can give some design ideas. That tools we can use for the development of software. Then again, some development constraints are there. That is also important. We have to study that. Every software has some conditions are there. In that conditions only we have to develop this. Constraints are nothing but some of the points where we have to restrict or project may require these conditions to run efficiently. So those are also some development constraints are there, like operating system we can consider, some type of hardware also we can consider, some type of different softwares also we can consider. They are required to develop this. And again we can consider as while doing this everything, what resources we have available in the company or at the developer side, that is also we have to check. So we can consider as a software engineering is a one discipline where we apply this all standard processes, techniques with the development strategies with the available resources, and we develop a finished product what is we consider as a product which can run in the market, which can be used by the society. Then again when we go into the systematic approach, what we consider as it is not directly that customer is coming to us and telling that please develop a hotel management project for me. So that time we have to consider that directly we should not start the particular coding, because still we don't have the proper requirements, proper what customer want actually. So this methodologies existed in the software engineering, so we can consider as the First step is taking the proper requirements from the customer, and once we take the requirement, again we can consider customer is, again we can consider the customer is a innocent. So if customer is innocent in terms of what, he don't have the knowledge related to our project, related to what my project should be. So that time we have to consider that whatever information the customer will give, that we have to take, and we have to analyze it, because maybe he can tell in the natural language which is not in a format. So we have to accept these all requirements and we have to analyze it. Once we analyze it with proper when we understand that what customer want, we can go for the designing. When we go into the requirement engineering, we'll in detail we'll study what are the different processes are there in the requirement. Whatever I telling is directly that analyzing, just like taking the information from customer and doing the study of it, and what customer want we will draw it, and we'll make a design. But actually analyzing is very big requirement, is very big method, right? So then after that, once the requirements are clear, we can go for the designing. Design is what? A blueprint where it can show that how the input is flowing from module to module to the output. So that design will clear why we require the design. So developer will understand which model should be developed first and which is later, and how they should integrate, and how the information will flow from module to module in the project. Once we have this particular block diagram, now the developer role will come into existence. They will start coding. Constructing is nothing but start coding using some programming languages. And once they will use some programming languages and develop it, ultimately when it is developed, we should test it. Otherwise, what will happen? Without testing, if we submit it to the customer, it may happen that lot of errors may occur. So to avoid this, we will do the testing at the in company also, as well as in the user location also, so that we can find really project is working according to the customer requirement or not. So like this we can consider software engineering is nothing but a step by step process by which we can develop the quality software for the customer. So now again we can consider as software can be a generic as well as custom. What the generic is specifying that mass people when you use some project, we can consider as it is a generic. But when we consider as a custom is what, when a particular user wants particular application or particular output from that particular project, so that we can consider as a customized project. Like we can for example, a scientific research is happening, maybe a scientist want related to his project some particular analysis of values related to maybe DNA analysis may be there, or weather forecasting may be there. So like these are the some customized project where we can use this particular project by the customer. The customer may use. So we divide this product into generic as well as customized. So then we should understand what is the difference between the software and hardware. Once we understood that, we can make the generalized software, and which can be used by the lot of people at a time, maybe a railway reservation system. We can see that a lot of customers may use this, and generic and as well as customized, specialized according to the customer requirement. When you make some specific project, that we consider as a customized. Now next is the software versus hardware. Next bit. What is the difference between software and hardware? So we can see that a software, we can see that it is a virtual, that we can see a coding, but we can't actually understand. We can't actually take in hand that particular physical touch sense we can't find in the software. It is what, a collection of code what we write by using some programming language. It is developed that by the developers, And we can see that it's complex because depending on the type of application, we can consider it is very much complex related to the development point of view. Maybe calculator, we can see that very simple, but again related to that I told that depth analysis of ocean. So we can see that a lot of parameters we have to take. Weather forecasting, a lot of parameters we have to understand related to the environment. So complexity is there in the software, and we can see that it deteriorate when we will see in the next slide what are the curves are there which are in the software and hardware, that time we will understand. So now we can understand that it will deteriorate. Deteriorate means what? With time being, if some changes you have to make it. So by changing the old code, it may create the new errors, and to combat that new errors, again we change something, again new errors. So like this, with the time being, we can see that due to the changes happening into the software, some errors may introduced, and that we have to minimize. So we can consider it will deteriorate with time being. And what are the different examples are there? We can give a lot of examples like application softwares are there, railway reservation is there, then system software compilers are there, Java compiler, TC compiler, operating system, which one is that? Windows, Linux, right? So like this, these are the software. So basically we should understand a software uh, which has a coding and complex as well as literate. Now come to the hardware. So in hardware we can see that it's a physical component. It is manufactured. Once the designs are clear, we can manufacture the same number of components again and again. Now again it is a simple, once the designs are clear, we can make manufacturing at the faster rate related to that product. Faulty pieces will remove it, and good pieces will use it. So we can easily, by looking to this particular hardware, we can understand something. Again it has a physical sense is there. Then different examples we can find, like mouse is there, keyboard is there, hard drives are there, right? So like this various examples we can find related to this hardware. Now one important point in this we have to understand is a wear out. What is a wear out? Wear out is what? Like in software it deteriorate, our hardware also wear out. Wear out means what will happen? Due to the mechanical contact between the components, it will deteriorate its performance. So therefore normally we see that uh, maybe bikes may be there. What will do bikes after some few years, 10 to 15 years, we have to send in a scrap, because we know that while running there will be a friction between the components. Maybe again best example in household also we can see that, like fans are there. When we use these fans, again inside this particular motor windings, some again frictions will occur. So like this we can see that it wear out, the performance of the component will deteriorate in hardware. So therefore normally we change this hardware after is expiry date. So that we have to understand, this is the biggest difference between the software and hardware. Software, we know that it will not wear out but it will deteriorate. Why? Due to some changes. So this is most